Hello students, in the chapter Quadrilaterals, let's solve exercise 7.2 in this video. First problem, ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and DA. AC is a diagonal. We have to show that SR parallel to AC and SR equal to half AC. Then PQ equal to SR, PQRS is a parallelogram. So we have to show all these three things. So in the diagram we can see that ABCD is a quadrilateral. Quadrilateral means any closed figure with four sides. Okay. And you have midpoint PQRS for the sides AB, BC, CD and DA. Okay. And AC is a diagonal. We have to show that SR is parallel to AC and SR is half of AC. That is the first one we have to prove now. Okay, so given data and to prove I have written from the question. Okay, so what we have understood from the question, it is written. Then, so now we are taking the triangle DAC. Okay, DAC. This triangle we are taking in that R is the midpoint of DC and S is midpoint of DA. Okay, it is already given in the question. Then SR parallel to AC and SR equal to half of AC by midpoint theorem. What the midpoint theorem says, that's what. So if the midpoint of two sides of the triangles is jointed, it will be parallel to the third side and that side will be half of the third side. So this only the midpoint theorem says, which I explained in my first video of this lesson. Okay. So now this is proved. Now taking the second triangle, that is BAC. Okay. This BAC triangle we are taking. In that similarly P is the midpoint of AB and Q is midpoint of BC. So by midpoint theorem, same way we can say that PQ is parallel to AC. Okay, this side, this PQ is parallel to AC. Similarly, and PQ is half of AC. How we set for SR? Same way for PQ we are saying that it is half of AC. So in the RHS of both the triangles, we can say that half of AC are same. Okay, so by that we can say that PQ is equal to RS. Okay, understood, because the RHS, both the equation we are having half AC. Okay, so that's why in the LHS we can equate it. So that is PQ is equal to RS. So RS parallel to AC, because from the first question what we proved that RS is parallel to AC, we proved no for the first subdivision. That's from the first question. Then PQ is parallel to AC. PQ is also parallel to AC, but for the second subdivision we prove. So by that we can say that SR is parallel to PQ. Okay, SR is parallel to AC. AC is parallel to PQ. That means SR is parallel to PQ. Okay, so that is also proved now. Also PQ is equal to SR. Okay. So also we had no PQ is equal to SR and they are parallel. So what it means, its opposite sides are equal and parallel. So PQRS is a parallelogram. So these two opposite sides are parallel and equal in length. So it is a parallelogram. Hence it is proved. Now second problem, ABCD is a rhombus and PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. So we can write the given data, that is ABCD is a rhombus and PQRS is the midpoint of the sides of the rhombus. Okay. So we have to prove that the line joining the midpoints, that is PQRS, is a rectangle we have to prove. Okay. So for that construction what we are doing, we are going to join AC and BD. Okay, so diagonals of the rhombus is joined. That is the construction. So proof in triangle DRS. So you have DRS, this triangle we are taking, and this triangle BPQ. Okay, these two opposite triangles we are taking. In that, DS is equal to BQ. So this DS is equal to this BQ. Okay, halves of the opposite sides of the rhombus. Okay, so you know that in a rhombus opposite sides are equal. All the sides are equal, obviously opposite sides are equal. So both are midpoints, so it is half-half. So both the halves will be equal only. Then angle SDR. So SDR. Okay, this angle. And QBP. This angle. Opposite angles of the rhombus are equal. Okay, this angle D and angle B are equal. Why? Because opposite angles of the rhombus. Then DR is equal to BP, halves of the opposite sides of the rhombus. Say how we prove for the DS and BQ. Same way, DR and BP also equal because half of the sides of the rhombus. So by that SAS congruency, we can say that these two triangles are congruent. Congruent means they are same in size and angle. Okay. Then so by that we can say that RS is equal to PQ. That is, that base of the triangle is there, no? That PQ and RS. So those two sides are also equal. Why? Because corresponding parts of the congruent triangle. Similarly, QCR and SAP, these opposite triangles we are taking. Okay. So in that also RS is equal to PA, halves of the opposite sides of the rhombus. Then the angle angle C and angle A, these opposite angles of the rhombus are also equal. Then CQ is equal to AS, half of the opposite sides of the rhombus, that is also equal. So by SAS congruency we can say that these two triangles are congruent. How we proved for the previous two triangles, same way these two triangles are also congruent. So that we can say that RQ is equal to SP. Okay, so these two base of these two triangles are there, no? That is also equal. Why? Because corresponding parts of the congruent triangle. Now in triangle CDB. Okay, CDB. This triangle we are taking. This half of the triangle CDB. In that, R and Q are the midpoints of CD and BC respectively. So we can say that QR is parallel to BD by midpoint theorem. Okay. So these two are the midpoints of the sides of the triangle. So it is so by the midpoint theorem we can say, no, it is parallel to the third side. Okay. So also PS are the midpoints of AD and AB respectively. So that we can say that PS is parallel to BD. Okay, this PS is also parallel to BD. How we set for this triangle? Same way for this triangle also we are saying by the midpoint theorem, and we are saying that it is parallel. Similarly, QR is parallel to PS. So PQRS is a parallelogram. Okay, so if the opposite sides are parallel, we call it as parallelogram. But angle PQR is equal to 90 degree. Okay, this angle PQR, this Q is equal to 90 degree. So in triangle PQ, so in PQRS, not triangle. So in PQRS, RS is equal to PQ and RQ is equal to SP from 1 and 2. Just now we said, no. So, and angle Q is equal to 90 degree. Okay, so PQRS is a rectangle. Whenever you have the angle in the parallelogram is 90 degree, then it's a rectangle. Okay, when you have the angle is 90 degree, then it's a rectangle. Now coming to the third problem. ABCD is a rectangle and PQRS are midpoints of the sides AB, BC, CD and DA respectively, show that the quadrilateral PQRS is a rhombus. Okay, first it is given ABCD is a rectangle, and the line joining the midpoints of the sides are rhombus we should prove. Okay, so for that construction we are joining AC and DB. So the diagonals of the rectangle we are joining AC and DB. Okay, then proof in triangle ABC. So if you see here ABC, okay, this triangle along the diagonal, this upper half of the triangle we are taking. In that P and Q are the midpoints of AB and BC. Okay, that we know. So by midpoint theorem we can say that PQ is parallel to AC and PQ is half of AC. Okay, by midpoint theorem we can say that. Then in triangle ADC, similarly in the second half of the triangle ADC, we can say that RS is parallel to AC and RS is equal to half of AC by the midpoint theorem. Then PQ is parallel to RS. Both are parallel to AC. What we said, PQ is parallel to AC and SR is parallel to AC we said. So both are parallel to AC. That means PQ is parallel to SR. And both are equal to half of AC. That means PQ and SR are equal. As in quadrilateral PQRS, one pair of opposite sides is equal and parallel to each other, it is a parallelogram. So now we can come to a conclusion that opposite sides are equal and parallel. So it is a parallelogram. So PS is parallel to QR and PS is equal to QR. Okay, opposite sides of parallelogram. So these are one opposite sides. Okay, similarly these another one opposite sides are there, no, PS and QR. This is also parallel because in parallelogram other two sides are also, opposite sides are also parallel and it will be equal. Okay, then in triangle BCD, BC and D, this triangle we are taking BCD. In that Q and R are midpoints of side BC and CD respectively. So by that we can say by the midpoint theorem QR is parallel to BD and QR is equal to half of BD. How we proved with the AC diagonal? Same way we are proving with the diagonal BD. That's it. Okay. So AC is equal to BD. Diagonals of the rectangles are equal. Okay. In a question itself it is given this ABCD is a rectangle. Okay, in a rectangle the diagonals are equal length. That's why we can say that AC is equal to BD. Okay, so here instead of BD we can take as AC also. That means from equation 1, 2, 3 and 4, find 5. Okay, all these equations together, what we can say that PQ is equal to QR, QR is equal to SR equal to PS. Okay, all these sides are equal. Okay, so that means PQRS is a rhombus. Okay, just now we proved that it is parallel, opposite sides are parallel, and we proved that all four sides are of equal length. Then we can say that PQRS is a rhombus, hence it is proved. So that's all for this video. I'll continue the remaining problems in my next video. Thank you, children.